Hello everyone, I am Mikołaj and I am Senior Backend Engineer on Product Intelligence team, and today I would like to welcome you to the Product Intelligence 102 session. This session is going to be focused on the high-level overview of what Product Intelligence is, what tools do we provide, and how to use them, and then how to utilize the data that these tools provides when building analysis in different use cases of our product. This presentation is going to be focused on the high-level overview and giving you pointers on the subject if you would like to take a deeper dive, because there's plenty of additional resources, and this should be just a jump start on the platform in order for you to explore them. So let's see what's on agenda today. First, I'm gonna discuss what the product intelligence is and what is the GitLab's commitment to the privacy protection. Then I would take a brief overview of our provided toolings, concluded with the decision framework, how to select one tool over another. Then I would briefly touch subject of instrumenting either of those tools. And finally, we'll discuss how to discover and use product intelligence data. So let's jump into it. What is product intelligence at GitLab? So product intelligence at GitLab is focused on providing the insights and information about what are the best places to invest people and resources, which product categories mature faster, and where can be user experience improved. To do so, product intelligence group and the data team collaborates together to provide data collection and analytics tooling with privacy focus manner that protects privacy and identity of our wider community members that trust us with our data. So about the privacy protection commitment, the product intelligence data collection is based on the trust that our users, the wider community, puts in a GitLab, and in order to strengthen our message about our goodwill and the intent how we want to use data, GitLab took the commitment to the wider community, and it is formalized in the 6 points, which goes as follows. We will not sell your service usage data. GitLab will not only add free JavaScript, as in freedom, to its core product. We pseudonymize personally identifier information about you, the user. We will transparently document the data we collect, how it is used, and how it's pseudonymized. We will alert the community when any change to our service usage data processes and/or policies occur. And finally, we will not implement telemetry in our products, which sends identifiable usage data to third-party products analytics services source. And for more details, you could take a look in a handbook. This privacy commitment is the foundation of trust we built with our wider community. And with that in mind, I kindly ask you to pay extra caution and be extra careful when dealing with the user identifiable information, and only use the tools provided by the product intelligence team to track them, because they are subjected to the pseudonymization to remove the connection between the user identifiable information and the user level product information. Okay, let's continue to the next section. So what is actually the product intelligence tooling that is provided? There's 2 main tools that are offered for GitLab developers to instrument and then collect and analyze data. First of it is service ping, and another is snowplow events tracking. So service ping is a tool that is available for both self-managed at gitlab.com instances, and it only collects the aggregated data and the instance settings, which means that it only can provide information about total number of issues on a given instance, or total number of secure pipelines that were executed on the given instance, or, for example, what version of Git is installed on the particular instance. However, it does not provide any more detailed information on either namespace, project, or user level. So it's, for example, impossible to collect information how many issues were created in each particular namespace. Then another things to remember when using the service ping, that this constraint is development is constrained by the GitLab release cycle, which means that the service ping implementation is delivered to the instances along the GitLab with the GitLab releases. So whenever the change was implemented in the GitLab code base, in order for it to be propagated, it has to be included in the release, and then the self-managed instances has to install this or update to this version. And it can sometimes take quite a long time, especially the instance update cycle. We are seeing, for example, the service ping reports coming from the instance running 10.0 version of GitLab. Next thing about the service ping is that it can be opt out on the instance level and is reported once per week from each of the instances that are decided to give us the data. On the other hand side, we have the Snowplow event tracking. This event tracking only works on the GitLab.com instance, but it provides the event data on the user level, which means that it provides much more detailed and context-rich information than the service ping, and it allows people that wants to analyze it to build the user journey and user stories that are going to be covered in the last section of this presentation, as well as more scoped information. With Snowplow events, one, for example, could collect information how many issues were created on each of the plans or subscription plans or in each and every namespace. Next thing is that it's because it's run only on GitLab.com, the changes are deployed in a continuous manner of everything else in the GitLab.com repository. Also, another thing about the Snowplow events is that the user may prevent front-end client-side events that are reported from the browser to be tracked, either by setting up the ad blockers or do not track browser setting. And finally, the data reporting cadence, events are recorded and reported at the time when they occur. However, the processing pipelines takes between 24 hours to 48 hours, but it's still closer to real time than the service ping reports. So from that comparison, let's narrow it down to these main questions that you may have. Which tool do I need? So in order to decide which tool to use, you need to analyze the use case that you want to follow and answer a couple of questions that will help you to point towards the right tool. So first of the questions would be the data availability. Could your use case only be analyzed from the SaaS offering, the GitLab.com, or you also need to have self-managed insights? If the self-managed insights is crucial, then you only could go with the service ping. If it's not crucial, then you could consider both Snowplow or service ping. Again, another question is data granularity. If you need the user level or the even group or project level insights, then there's only option for the Snowplow to deliver. However, if the instant level aggregates are enough, then you could consider both Snowplow or service ping, depending on the other aspects. And again, the next question is the lookback ability, or the ability to include the historical data. For the Snowplow tracking, it can only be delivered with the already existing events. I would cover them later on. There are some cases that it could be delivered, but for the other ones, you need to first instrument the events, then only you could collect the data. For the service ping, in the scope of the database, some of the methods in the service ping are driven from the database, some other from different sources. But in the scope of the operational database that covers most of the metrics, it can be used to track back the historical data. For example, with the service ping, you could instrument the information about how many issues were created since the instance was set up. For more detailed information, you can follow the link on the bottom of the slide. The next, let's go into the briefly overview how to instrument each of these tools to collect the data that you need. Starting from the service ping, The service ping uses what is called the instrumentation classes, which is the framework which was inspired by the active jobs or the site background processing, where the instrumentation classes that provide the information about the metrics can be considered or are similar in the idea to the sidekick workers that are executed and do some work. In this case, these classes are executed and provide the data back. And there's a piece of configuration later on that tells the underlying infrastructure how to execute them and how to build the payload out of that. So let's start from the beginning. The instrumentation class. In order to create the metric, you need to create the instrumentation class. And there is res generator for it. You can follow the link on the slide to visit the documentation page and get the details on the syntax, how to execute the generator. It will provide you with the Ruby file with the instrumentation class, and you need to fill its body, and also with the spec file that can be used for the testing purposes. On the right side of the slide, you can see the example database metrics, which is with field attributes in its body. Once you prepared the instrumentation class, the next step is to create the metrics definition YAML file, which is, as I mentioned, kind of configuration, like, for example, Q files in the Sidekick, which provides some metadata information along with configuration pieces. And again, there is another Rails generator provided that you could execute to get the get your file prepared for you. And you also only need to fill out a couple of details about the metadata and some configuration pieces. To conclude all this process of instrumentation of the service ping metric, I want to also point one gotcha. So in case of the database metrics, if underlying database query would be too heavy and cause too much of a performance cost, it may time out and fail to report the data. If that's the case, there is a link to the guide included on the slide that you can follow that will help you to optimize the query. Also, on this slide, there's included link to in-depth video tutorial that walks through instrumentation and creating a definition and in the end testing of service ping metric. And now let's move on to the Snowplow event and how to instrument it. Snowplow events can be reported from various layers of the application, including front-end and back-end layer. And there's a number of different APIs that are available depending on the use case. For the front-end layer, one can use either data track attributes or Vue.js mixin or Row.js tracking. And for the backend or the client backend side or the server side tracking, there is the Ruby module that GitLab tracking that offers event method that reports Snowplow event when called with appointed attributes. There is the link to the video tutorial that goes in detail how and when to use those tools to instrument Snowplow event. Finally, when the event is instrumented, you can verify this event or discover a new one, discover the existing events on your local instance using the GDK, included in the GDK Snowplow micro service, which is the Dockerized application that collects Snowplow events on the local instance and reports them back to you so you can browse them. We're gonna gonna talk a little bit more about Snowplow micro towards the end of this presentation. And the final piece to the Snowplow events instrumentation, as I mentioned before, the ad blockers and the do not track setting can prevent events from being reported from the local instance. So when testing the events with this Snowplow micro, please do remember to disable them in order to get the full picture of what's happening. So once we walk through all the tooling that we have, that there is, and also how to use it in a brief, I want to have a chat about discovering and using existing product intelligence data. There is already almost 2,000 service ping metrics, over 200 of Snowplow custom struct events, Also, on the every page of GitLab, when the page is loaded, Snowplow page view event is tracked, providing quite a broad metrics library for you to use. But then how to discover those metrics and how to understand what you could use to get the insights that you need. First place to discover the service ping metrics is the metric dictionary. This is a page that was created by the product intelligence team and that provides overview in all of all service ping metrics. It also has the search bar that could use to filter the metrics for a term that you want to check. So if you would like to, for example, check all the metrics about the issues, you could type issue into the search bar, and then you got the list of all the metrics that contained the term issue. And you have this column of description that provides a brief explanation what this metric is about. Another handy thing in the metrics dictionary is this column with the copy query to clipboard button that allows you to copy SQL query that can be used to get the data from this particular metric in the Sisense, which is the business visualization and analytics tool that is used to work with the product intelligence data at the end to build the charts and the dashboards that we're gonna visit a little bit later in this presentation. So back to the list of tools that are also available. Another way to discover product intelligence data is Snowplow Micro, which I already mentioned, that can be run on the local environment and records the Snowplow events during the user journey, during your interactions with your local GTK instance. And yet another tool for the Snowplow is dedicated section of this metrics dictionary, which is the Snowplow section, which provides information about the all Snowplow events, all custom Snowplow events, and you could also search through it, for example, with click, and you can see that all clicks that were instrumented with some additional information that may help you discover the custom events. Last but not least, there is documentation from the data warehouse that powers the business visualization analytics tool Sisense that you can visit in order to understand what tables are available. So how this data that was instrumented via Snowplow or Service Ping was transformed and made available for the GitLab members to build the analysis upon. This documentation provides insight about all the tables. Not all of them are available at the business layer. Some of the production layer, which is available for everyone to use. Some of them are intermediate tables. So when using this documentation, it's handy to go to the database tab and visit only the prod database. There's a couple of schemas that are included inside, and they are all available in the business visualization tool Sisense. That concludes all the tools that are available and that can be used to discover existing either Service Ping or Snowplow data for use. So now with this intro, let's jump into the actual example, and let's try to use existing product intelligence data to create some kind of analysis. The use case that we're gonna follow is understanding how many users creates the new merge request using plus button from top button navigation. In order to achieve this, we're gonna follow the two steps process. First one is to discover with Snowplow Micro events that are triggered along the journey and help us to distinguish it and build the analysis on top of them. And then we're gonna head to the Sisense to actually build the SQL queries and populate the chart. The final chart, the final result of this exercise is the funnel chart that can be seen on the right-hand side of the chart. For the sake of keeping this presentation brief, I am gonna only implement the first step of the funnel during this presentation. However, if you want, there is a link below that you can follow to get the full and very detailed presentation of building the full funnel just with the Snowplow data. So with that, let's start work. So first, I'm gonna use Snowplow Micro that is included in the GDK, and using the how-to documentation from the GDK section, which is linked from the slide here. You can enable it for your local GDK instance and start collecting data about what events are available. It offers a couple of endpoints that can be used to interact with it. So let's begin. First, we're gonna clear out the Snowplow microstate, so it's easier to discover what we are looking for. Then let's go and actually trigger or perform the action that we want to track in the GDK. So there is this plus button, and there is this new merge request drop-down option. So let's click on it, and then we will go back to the Snowplow micro and check if there is any event that can help us to understand this interaction. Okay, so the page, new merge request page has loaded. So all the events that could be recorded probably were already triggered. Let's check if any event was recorded. We got 8 events in total. Let's see what was recorded. So first, let's check at event types that were recorded. There are a couple of different types of events. So let's cover all of them and help us understand which would be the most useful in this case. So we had struct events, unstruct events, page views, and page pings. First of all, we can discard all unstruct events. Those are deprecated events that are no longer supported and shouldn't be used for the product intelligence analytics purposes. So that left us with the struct, page view, and page ping events. Page view and page ping events are the automated events that are available whenever user loads the page or interacts within the page, provides information about what page they were triggered on, what was the page referrer, and some additional context information, oftentimes including namespace, project, pseudonymized user. And the other type of event, which we have here, is struct events. Those events are the custom events that some developer or some member of the wider community decided to include in the GitLab code base to track specific action that was of an interest to them at that point in time. So let's start browsing events one by one to see what's inside. So we have struct event first. Let's go inside. Struct events carries most of the information in the fields that are prefixed with the SE prefix. And there are category, action, label, and property. And as we can see, those are the attributes that developers fields when instruments the event. This one is about rendering the side navigation, which doesn't really match our use case. So let's skip over that and follow the another one. This is the unstruct, which is deprecated, so we are not gonna look inside it at all. And there's another struct event. Let's look inside. And in this, we have the action is click link new MR, which looks promising. And the label is plus menu dropdown, which exactly match our use case, which is perfect. Let's record those down and then use it in the we will later use them in the size sense to build our analysis. So I am just taking a note for the future. We have action of clink link new MR and label of plus menu dropdown. So since we already have the event that we want to use to build our visualization upon, we can continue to the next step, which is building the sisense chart to visualize data. So let's go to the sisense. As I mentioned, this is the business analytics business visualization tool. And we're gonna go to the new exploration tab that allows us to play around and check the data and draft some charts before we actually create the dashboard. So as I mentioned, to get the sisense works on top of the data warehouse. So in order to interact with the data, we're gonna use the SQL queries to extract the information that's gonna be transferred by sisense into the charts. So let's start some query. And now there's the question about which table should we use to get the information in which table the snowplow events are stored. So let's use the search bar to find anything that has snowplow. And we can see there's a couple of these tables in the legacy schema that were returned. So let's look into those. The first one with snowplow prefix is events cons all. That doesn't really sounds like the one we could use. We have then snowplow GitLab events 30. So let's check if this table would work for us. For that purpose, we can use the mentioned earlier, the data warehouse documentation page. When we can just search for this model, snowplow events 30. So we have it. Let's go inside. There's this description piece here that can help us understand what this table is about. And this one says that this is a view over the last 30 days of GitLab, snowplow GitLab events. If we continue reading the description, there is a piece that says this model is being phased out in favor of snowplow unnested events 30. Okay, so we probably shouldn't use this one, but we should use this unnested events one. First, let's check if it's still available or this recommended is available for us. And it is. Awesome. Let's also take a look into the documentation to better understand this recommended table. And it said this view is over last 30 days of snowplow unnested events all based on the ref timestamp column. So we know that it's narrowed to the last 30 days of data. We can also check the different columns that are gonna be available. We can look for the one that we just find out in the events by the snowplow macro that we want to filter on. So let's check if there is action and label, and there is the SE action, and there is also SE label. That's awesome. And let's also finally check if there's anything about the user. So let's see. So there is GSC minimize user ID, and this one is the one that's recommended, and that carries the hashed information about the GitLab user ID that is transformed in a way that can be tracked back to the resulting user ID. However, it provides the deterministic and stable across the multiple sessions information about the single entity that interacted with GitLab. It can be used to build the user journey, user stories, and it's recommended to do so. So since we already have all the columns that we're gonna use, we can get back to the Sisense once again and start building the chart with this information that we just find out. So from legacy snowplow unnecessary events 30, we're gonna count distinct pseudonymized user IDs. And we also need to filter it to the events that we are interested in. So as a label should be, and let's use the information that we noted down just a moment ago. And action and execute the query to get the results and turn them into the chart that will show us how many users in the last 30 days clicked on this link. And we got the results back. Let's turn them into, for example, bar chart. And as you can see, it was almost 1,800 of distinct users that performed this action within the last 30 days. And that would conclude for the this example use case. For the more in-depth tutorial that includes the rest of the missing steps from the funnel, which is new merge request creation, and then checking if the merge request is actually created, you can take a look at the attached video tutorial. Also, there is a linked handbook page for the details about the Sisense. There are a couple of handy courses that you can follow there to get more hands-on and knowledge about how to use the Sisense effectively. And that would conclude our example use case. And the last piece of the information that I have ready for you in this presentation is pointers to the set of the additional resources that may help you in succeeding with the usage with the product intelligence. So first of all, there's a couple of links to the service ping and the snowplow documentation. There's also product intelligence handbook guide and getting started section, as well as the FAQ that may covers the questions that may arise for you. Another information that I would like you to know is that Product Intelligence Group is hosting office hours every week in alternating time zones. So whenever you feel like you're missing some information or you get stuck when working with the Product Intelligence tooling, please don't hesitate and pay us a visit and ask your questions. We'll be happy to help you. And last but not least, there is the Product Intelligence Group Slack channel that you can also visit and ask questions if you have some. Thank you very much and see you sometime.